Okay, today's topic will be benefits of using Modbus TCP-based dual Ethernet port I/O modules. We'll be introducing our ET7000 series and 7200. Here's our agenda for today. First, we'll go over the cost benefits of being able to use daisy-chained Ethernet I/O modules. We'll introduce our new ET and PET 7200 product line. We'll show comparison between traditional Modbus TCP data acquisitions, our traditional ET7000 series, and our ET7200 series Modbus TCP data acquisition modules. And we'll go over some sample applications and show you how to configure the ET7200 series, very much like our ET7000 series. ICP-DOS was established in 1993. We're headquartered in Hsinchu, Taiwan, and ICP-DOS USA was launched in 2001 to support the North and South American markets. ICP-DOS is ISO 9001, and we're a Windows embedded partner. Modbus TCP protocol. Modbus RTU was developed in 1979 by Modicon, now owned by Schneider Electric. The benefits of Modbus are it's open source and royalty free, and has become the most commonly used protocol for industrial applications. It's a serial-based protocol normally communicated over RS-485, which allows you to daisy chain up to 255 devices along a single bus or COM port. Modbus TCP was developed in 1999. It's similar in structure to Modbus RTU, but it's implemented over an Ethernet network. Larger networks are possible due to Ethernet communication being faster and more easily expandable, and devices traditionally have a unique IP address to differentiate as opposed to node IDs or addresses. The benefits of using Modbus TCP are, of course, it communicates over Ethernet, and Ethernet is everywhere nowadays. Modbus TCP also allows for easy expandability and the ability to easily move nodes from one location to another or add additional nodes. Just plug into an existing Ethernet port. Faster communication speeds are available. It's expandable through the internet using public IP addresses and port forwarding. You could allow multiple master devices as opposed to Modbus RTU, so like a SCADA system and a PLC can both read the data from the Modbus TCP slave device. And drivers for most of software are available for both Modbus TCP and Modbus RTU. Here's a typical illustration of how a Modbus TCP system would be implemented. There would be an Ethernet switch in the middle, connecting all the multiple slave devices to either one or multiple master devices. In this case, we're showing a PC, which is acting as a HMI, and our touchpad controller, but it can be any Modbus master device communicating to each of these individual slave devices on the right, reading the various digital I/O and analog I/O and controlling the outputs as well. Modbus RTU and Modbus TCP are open source and royalty free. They're easily implemented and added to third-party devices. Modbus RTU is the most popular industrial protocol, but Modbus TCP is definitely up there in the top also. Most automation hardware and software offer some way to communicate to both Modbus TCP and Modbus RTU devices, whether it be through driver, OPC, through a gateway, or communication port. Modbus is great for applications like PLC, SCADA, data logging, and automation. Modbus TCP and Modbus UDP are supported by our Ethernet I/O modules, specifically our ET7000 PET 7200 and ET7200 series. They are configured using a web browser. We'll show you how to do that in a few minutes. They have the ability to communicate to OPC server, have built-in security mechanisms to allow for IP blocking and other features as well. The modules have diversified I/O interfaces with various analog and digital configurations. The ET7200 and PET7200 have the additional feature of overvoltage protection, relay outputs, timer, and counter modules, plus they have dual Ethernet ports, which we'll show you in a minute. This is an illustration of the standard ET7000 or traditional remote data acquisition modules from Modbus TCP and the ET7200. Note at the bottom that there's 2 Ethernet ports per 7200 module, so it allows the ability to daisy chain. For the PET modules, only the first module has PoE. The PoE is not passed from module to module. So each the second, third, fourth, and fifth module, those are PET, must be powered remotely by power supply through the terminal block. This reduces the number of Ethernet ports required and Ethernet switches. So in this configuration on the bottom, the PLC or controller connects to one port of Ethernet switch, and a single port is used for the slave devices, which are daisy chained onto each other. Versus the top configuration where each individual slave device and master device must have its own Ethernet port, and because this illustration shows that you need more Ethernet ports, you have to connect an additional switch as well. Some additional features of the ET7200 are communication security. It has the ID and password for logging in, and there's the ability to do IP configurations or DHCP. The protocols are Modbus TCP or UDP. There's a dual watchdog feature and communication watchdog. Power on and safe values for outputs, and the ability to do I/O pairing where the inputs on one module can mimic the outputs on a second module. And the ET7200 also has LAN bypass, so if power were lost to one module, the Ethernet communication would still go through to the third module in the illustration below. For the ET7200, there's LEDs, indicators for the digital inputs and digital outputs. There's a reset button, which wasn't on our ET7000 series, and there's two pairs of power input pins for a backup power supply or redundant power supplies. Here's a side-by-side comparison of our 7000 series versus our 7200 series. They're almost identical except for the fact that there's more pins available on the PET series. There's 2 Ethernet ports and a reset button. Oh, and the LED indicators as well. Here's our part number breakdown and a comparison of the 3 different types. We have our tiny modules, which are the TET and TPET series, where the P stands for Power over Ethernet. Let's see, the ET7000 and PET7000 are shown in the middle, and the ET7200 and PET7200 are shown on the far right. The size of the module gets a little bit bigger for each, and the number of I/O pins also. On the 7200, again, there's a reset button, which is a nice feature, and the LED indicators, which show the status of the digital inputs and digital outputs. This is just an illustration showing our PET models. Again, for our PET 7000 series, it's only got one port, so you can connect it directly to a PoE switch for PoE power. For the second picture, the PET 7200 series, PoE power is only applied to the first module. Only Ethernet communication is passed using the output port or second Ethernet port. Now I'll show you a quick video showing how to configure an ET7255 and connect it to Easy Data Logger. Let's see. Oops. In the final video, this will be embedded in the slides, but for better resolution, I'll show it to you this way. Okay. So the first thing you must do is connect the ET7200 series to the PC. You open our Mini OS 7 utility to scan for the module. Once it's found, you can use this utility for setting the IP address. Then you can rescan for it and see that the IP address has changed. In this case, it went from 192.168.255.5 to .1. Then you can open up the web browser, Internet Explorer, type the IP address of the module in it. You log into it using the default password, in this case, admin with a capital A. And this is the ET7200 configuration screen. The configuration, the Ethernet settings are shown here. The basic settings, which just have the model name and the Modbus TCP port, and the most important being the Modbus or module I/O settings. In this case, you can enable the counters, set a preset for the counter, set power on and safe values for outputs. Then using our web HMI, you can view the status of the I/O to test your wiring, make sure that your inputs turn on when power is applied to the input, and you can control the outputs using the buttons on the bottom right, and you want to make sure that communication status at the bottom shows good. If communication status is good, you're live and connected to the module, and you're reading the data properly. Once we do this, we can open up Easy Data Logger. The first thing you must do is create the connection via Modbus TCP. So you click the Install button, type the IP address of the slave device, and note that it's port 502. Click Install, add the device. Most of our modules are available in the drop-down list, which are pre-configured. For the ET and PET 7200 series, they're not in the list yet, but they will be added shortly. For now, we can go to the bottom and just enter the numbers numerically. Each of these devices, this module in particular, has 8 digital inputs and 8 digital outputs numbered 0 to 7. So we'll create that and close these two screens. And then under the DI channel list and DO channel list, we'll add all the channels to be logged or monitored. And when we expand the plus sign next to it, you'll see all the channels listed. From here, we can start our project. And we want to note on the far right, the device state. Once the light turns green, we'll know our device is connected and we're reading our real-time data. We'll switch back to the web HMI so that we can control the outputs or turn some on so that you can see that we're reading actual data. Note that on the far left and on the bottom screen under track 1, some of the values turned accordingly based on what we changed in the web HMI. Now we'll just turn them all on, and we'll switch back. And note all the channels, or all the outputs are on. Switch back again, turn them all off. Oh, and all of them are off except for that one. And that's shown by the orange line at the bottom. Okay, that's how to connect to Easy Data Logger. Now we'll show a second video which shows how to connect to InduSoft. So we'll start in the same place where we have our connection to the ET module through the web interface to control the I/O. Let's expand it. Let's press play. Now we'll expand it. Okay, so we'll turn all the outputs off to begin with. And then we'll open our InduSoft software. And this is the opening screen. Actually, first we'll run the PC demo, just showing you a few of the features of InduSoft and some industry examples. This is the PC demo for InduSoft. You can see InduSoft has the ability to do animation, alarms, tables, graphics. There's many industry examples. Since this example does come with InduSoft when you first install it, you can see how some of these objects and illustrations and animations are created, and maybe copy some of these over to your existing projects or future project. We'll show some of the ActiveX controls, the combo boxes, radio buttons, check boxes. Here's an alarm window. And we'll just exit this, and we'll show you how to connect the ET7200 or any Modbus TCP device to InduSoft. So first thing we need to do is create a new project. Then we'll click on the Communication tab to create our Modbus TCP connection to our slave device. To do this, we have to select the Modbus TCP driver from the list. Click Select, it shows up at the bottom. Click OK. Now click on Driver to expand it, and you'll see MOTCP there. We'll edit the main driver list. We'll add our tags. Well, in this case, we'll add, I think, 4 tags. Number DO0, DO1, DO2, DO3. And let's see, if you need help in what to put in each of these fields, the help documents in InduSoft can be acquired by right-clicking on the MOTCP in this case. And there's a driver sheet which shows you how to, or what to put in each field. In this case, for the station, we put the IP address, colon, 502 for the port number, and colon 1 for the device ID in this case. And we'll copy this over for each of the 4 tags. So again, it's IP address, colon, port number, and then colon device ID. So 1.255.1:502:1 for the station ID. And the I/O address, these are coil registers, address 1, 2, 3, and 4. And if they were like holding register, it'd be starting with the 4x. Inputs or input registers are 3x, and digital inputs are 1x. So once we've created our tags, we need to save this. And then we can create our graphic screen to show the values on the screen. Do this, we'll create a screen, do main. We can put a background picture by enabling the background if we want. In this case, this example, we'll just change the background color from white to some other color. I think we'll pick blue in this case. And note the background color changed. Then we can use the text to just type a description. Digital output state. Put a description showing what tag name it is. In this case, DO0 through DO4. Actually, we'll do DO0 to DO1. And we'll show you some functionality of the buttons. So we'll first create a label widget to show you the existing value. To do this, we'll use the text box widget. By clicking on properties, we can get to where we enter the tag name. If you want to change the font, you can use the font button right there. Shown previously, if we save this, we can verify that we selected the right tag. On the project. It's very important to put an exit button, otherwise it makes it hard to exit the screen. So we'll quickly add an exit button, then we'll save again. And then we'll start our project. Status is 0 now. We switch back to the web HMI. We could change the first output to on, and if it is the correct number, we should see it change to a 1, which we do. So we can turn it off, go back, it turns off. So now we can quit the project and add our buttons to control the outputs and add a second label box for this second output. Again, text box, properties, set the tag name, in this case DO1. Now we'll add a button. Add a second button. And the third button will show you the reason for this. We're going to create an individual on and off button, and we're going to create a toggle button. So this will be our on button, so we'll add that caption so that the user will know. Then we'll use the button feature of set tag, and we'll choose our tag. Create an off button. The command will be reset tag. Select the same tag name, DO0. That should in DO0. And this is on or off. And we use the toggle tag. And this will just change the value between 0 and 1. Save this. And we'll quickly run this. Oh, save first, and then run. Whenever you make changes, it's very important to save. And we'll go back to the web HMI and see the status. Both are on. We'll turn them off through the web HMI, and we should go back to InduSoft, see both off. And one on, one off. Okay, so we can stop the video now and go back to our presentation. And I just want to show you a few industry examples. And here. Okay, some of the industries that ET7000, 7200, and Modbus TCP data acquisition modules in general are used are industrial automation and SCADA applications. They're very popular in solar applications for solar monitoring, manufacturing and conveyor applications, food processing. We sell a lot of these to use with our SCADA systems, specifically our Easy Data Logger and InduSoft. That's shown there for inspection systems. Laboratories, you can use it with LabVIEW, automotive, robotics, many different industrial applications and building automation. Some of the complementary products which work well with these are, let's see, for these, since they're Ethernet based, an NS205 5-port unmanaged Ethernet switch can be used. And for our PET series, our PoE switches, in this case our NS205 PSE, which puts out the 48 volts and 15.4 watts for powering the PoE devices. Or if you just want a simple power supply, our new EPR series puts out 24 volts. We have 3 different models with various mounting options available in 25, 50, and 100 watt versions. And they're DIN rail mountable, and we have a few DIN rail mount options. If anyone has any questions, I'll unmute and you can type it in the chat box as well. Let's see, if you have any questions afterwards that you forget, you can always email us or call us as well. Let's see. Is InduSoft software free? No, InduSoft software is not free. Easy Data Logger is free. InduSoft is purchased based on tag names, or I'm sorry, tag number, and there's a runtime and development license or a combo license with both runtime and development. Register tables are provided in a separate register manual for all of these Modbus TCP modules. And for the TET series, they're in the user manual. The ET7000 and the ET7200 are available with analog inputs and analog outputs as well. The TET series and TPET series are only digital I/O at the moment. Does anyone else have any additional questions? This video will be posted online after the presentation. Okay, if no one has any other questions, thank you for attending, and we'll see you next month for our next webinar.